Hey everybody, this is Larry. This is day 13 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I don't know what time this is, so hopefully not soon. Otherwise, I don't usually cut and everything is live and everything. But if the server goes down, I might actually cut it and then come back later. So that's my disclaimer and warning. Excuse me. I like to do everything live, as you know, so I definitely usually keep it that way. But I guess that's my warning. Today let's take a look. 2037 minimum number of moves to seat everyone. It's a easy problem. There are n seats and n students in a room. You're given away seats of length n, and the seats of I is the position of the ith seat. You're also given the away students of length n, where students of j is the position of the jth student. You may perform the following move any number of times. Increase or decrease the position of the ith student by 1. Moving them okay, maybe. No students are in the same seat. Note that there are multiple seats or students in the same one. Okay. So what does this mean? Seat is don't know that. Okay, so I've seat. Do they have to go to the same seat, or how does this work? Like 2 to 1, 7 to 5, and then 4 to 3. Okay, so yeah, I mean, I think the way that I would want to think about it, I mean, I know how to do this. It is easy, but I think it is important. So I'm bringing up the drawing. I don't know why something is stuck. I need to untangle some mess here. Okay. I think it's important to understand why it works, right? Because so this is a sorting problem. And in sorting, you're exploiting a structure that you're creating to be able to solve the problem in an easier way, because there's a structure in this order, right? And one thing about this order is that allows you to do greedy algorithms in general. Not always greedy, sometimes there are other things, but there's stuff that exploits that structure, which is sometimes or very often in a greedy kind of way, right? At least, I don't know. So here you have 315, and this is the input for the seats, right? I'm just looking at the first example, 274. And the thing is that there's many ways to kind of order this, right? There's 3 things, and then there's 3 seats, so you can kind of match them in 3 factorial, which is 6 number of ways, and you can maybe brute force all 6 and then try them more. Of course, in this case, n is 100, so n factorial is probably not a good idea. But the idea here is that, okay, how do you kind of match this, right? And the idea, of course, and this is an easy problem, so maybe you have this intuition, it's just to sort these things. So you have 1, 3, and 5, and then you have 2, 4, and 7, and you just kind of do the math for matching these things, right? And and that's pretty straightforward conceptually, in the sense that you could say, oh, it makes sense, it's intuition. And of course, intuition always works until it's wrong, and then you're like, oh, well, I guess I never understood it, which is why I'm kind of doing this thing. But the idea why this works is that you can kind of, here you could see my arrows, and in a very straightforward kind of way, you have to exchange argument, right? Because let's just look at these 4 things, right? Because you can generalize from those, using induction or something. But you have 1, 3, 2, 4, and then you want to match this and this, right? But then the exchange argument, of course, is that you have 1, 3. Let's say you have, and then you do this thing, right? You match these things. The idea here, though, is that this will always be. This I'm pointing at the bottom one. It's always going to be suboptimal to this one, and there are a couple of ways you can improve it. One is, well, the exchange thing, but more in a more mathematical intent kind of way. You could just say, okay, well, let's say let's actually rewrite this as A, B, C, D, right? Where let me erase some stuff real quick. Let me just erase everything, right? So basically, in a more general form, you could have like A, B, C, D. I mean, the other one you can probably do very quickly, and now of course you have that because they're sorted. And let's just, without loss of generality, you could just do A is strictly less than B and C is strictly less than D, right? And of course, in this case, then now the cost is going to be so there are two ways, right? So it's A minus C or whatever, absolute value, right? Yeah, I mean, I guess it's the absolute value though they don't give you the formula for this one. I think I just kind of skipped it in my head, which maybe is my fault. Oops, why did I have a plus here? So you have this, and then you want to make a comparison to A minus D plus B minus C, right? Yeah. And I think the way that you can kind of do this is by this one's a little bit annoying, I think, but you can still do it. I don't think I'm going to do it here for this video. That's why I'm like kind of pausing and trying to think about it. But the way that you can do it is just by going through all the cases of A is greater than C, and then maybe the other one, which is A is less than C, and then you have B is greater than D, and then you kind of just do all the possibilities, right? And there are 4 of them, and if you go for all 4 of them, you can just basically do the proof on these formulas and show that this one will always be more optimal or equal. I'm kind of a little bit lazy, like I said, because it's just a lot of things. But one thing that we can maybe, just to show you how to kind of kick it off, let's just say only this is true for now, right? That means that here you can rewrite the formula without the absolute values, just for the, because A is greater than C, so you know that that's going to be positive, right? And so forth. And keeping in mind that A is still less than B, right? Because then now this is positive, this thing is positive, this thing is positive. B minus C is always also positive because B is greater than A and A is greater than C, so you have the transitive thing. And then A is so this is actually unknown, but yeah, I don't know, I guess this is unknown. But you can actually rewrite this, right, as A plus B minus C minus D or something, or minus C minus D, and then on the bottom you have, I guess, the same thing. So I guess in this case, is this true? That doesn't sound right. Something is off, because then they shouldn't be equal. My thing on this one is really wrong. Did I miss something? Well, I guess the reason is because I think this is actually technically still absolute value. But yeah, but then now out here, because I think this one is why I said, yeah, okay, that makes sense. You can't take away the absolute value on this one, which is why I didn't say this has to be positive, which means that now you have this form instead. And then there's only two versions, right? One is, say, A is greater than D. And where A is greater than D, you have this formula, which means that they're equal. So if they're equal, then, yeah, then it doesn't change anything, right? But then if A is less than D, then what do you have? Then now you have D minus A here. So then now you have D plus B minus C minus A, and then you can show that this number is is greater than here, right? Because the B cancels out, the C's cancels out. So then now you have A minus D on top and D minus A on top. But we all on the bottom. But we already established that A minus D is negative, right? In this case, because that's just what we said, right? Which is why we have D minus A as the positive. And so that means that by definition, this is smaller, right? So yeah, so that's basically the idea. I don't know if this is helpful. I think I went a little bit too nutty on that one. But that's one, so that you can reproduce that proof for all the other variations. But that's basically how I would think about it, right? Is that in this way, you will always, do the exchange argument. And in this way, then now it enables you to do the greedy solution, which is sort. And then now for a seat student in SIP of seats students, yeah, minus student, right? Oops. And that's it. It's a very long video for just saying this, but hopefully the proof kind of makes sense. 1535 day streak. Yeah, I mean, of course, this is going to be n log n. Yeah, n log n and of n space because of the sorting. Yeah. That's all I have for this one. Let me know what you think. Thanks for watching. Hope the proof is useful. It does come into play in other things if you really want to go into proof. And today I just wanted to kind of show you like an example. So that was kind of annoying, so I don't know. But I just give you one example, right? Yeah, that's all I have. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.